Good morning, sir. This is Aimilo Felicilda Obamin from Bachelor of Science in Accounting and Information System. So for today's video, I am going to tackle all the given topics, which includes the first topic, the data warehouse of physical design steps. So let us begin with develop standards. Standards provide a consistent means for communication. Standards takes greater importance in the data warehouse management. So this is because the use of the object names is not confined to the IT department. It ensures consistency across various areas. So developing standards allows technology to work seamlessly and establish trust so that markets can operate smoothly. The second one is create aggregates plan. So in this step, review the possibilities for building aggregate or summary tables. You will need a comprehensive plan for aggregation. The plan must spell out the exact types of the aggregates you must build for each level of the summarization. So it is possible that many of the aggregates will be present in the OLAP system. The third one is determine the data partitioning scheme. So partitioning divides large databases tables in manageable parts. So you should always consider partitioning options for fact tables. It is not just the decision to partition that counts based on your environment. The real decision is about how exactly to partition the fact tables. So these are the different partitioning scheme including the first one is the fact tables and the dimension tables selected for partitioning. The second one is the type of partitioning for each table, the number of partitions for each table, the criteria for dividing each table, a description of how to make queries aware of partitions. And the number 4 is establish clustering options, so the fourth step. This technique involves placing and managing related units of data in the same physical block of storage. Examine the tables table by table and find pairs that are related. This means that rows from the related tables are usually accessed together for processing in many cases. Then make plans to store the related tables close together in the same file on storage medium. So the fifth step is the prepare and indexing strategy. So this is the crucial step in the physical design. Unlike OLTP systems, data warehouse is query-centric. So as you know, indexing is perhaps the most effective mechanism for improving performance. A solid indexing strategy results in enormous benefits. So the strategy must lay down the index plan for each table, indicating the column selected for indexing. The sixth one is assign storage structures. So in a data warehouse, you are not just concerned with physical files for the data warehouse tables. Your storage assignment plan must include other types of storage such as temporary data extract files, the staging area, and any storage needed for front-end applications. So let the plan include all the types of storage structures in various storage areas. And the last step is complete physical model. This is the last step. This is the final step, which reviews and confirms the completion of the prior activities and tables. So by the time you reach this step, you have the standards for naming the database objects. So you have determined which aggregate tables are necessary and how you're going to partition the large tables. You have completed the indexing strategy and have planned for other performance options. You also know where to put physical files, and all the information from the prior steps enables you to complete the physical model, and the result is the creation of the physical schema. So let us now proceed to the next topic, which is optimizing physical storage. So in this subsection, we will examine some techniques for optimizing storage. The first one is set the correct block size. So a data block in a file is the fundamental unit of input or output transfer from the database. So to memory where the data gets manipulated. Each block contains a block header that holds control information. The block header is not open to keeping data. Too many block headers means too much wasted space. So generally, increased block size gives better performance, but you have to find the proper size. The next one, or the second one, is the to set the proper block usage parameters. So most of the leading DBMS allows you to set block usage parameters at appropriate values and derive performance improvement. So there are two parameters govern the usage of the blocks and proper usage of the blocks enhancement performance. Starting with a generic example of these two parameters, which is block present free 20, which this parameter is set at 20, that rows 20% of each table block is reserved for expansion of records. So therefore, setting this parameter at a high value results in too much wasted space. So the general rule is to set their parameter as low as possible. And the next one is block present 40. So block present used 40. This parameter sets a watermark level below which the amount of space used in a block must fall before new records are accepted in that block. So there are hardly any deletes except when archiving out of the data warehouse. So the general therefore is to set this parameter as high as possible. And let us now proceed to the third techniques for optimizing storage, which is the managed data migration. To manage data migration, when a record in a block is updated and there is not enough space in the same block for storing the expanded records, then most of the DBMS move the entire updated record to another block and create a pointer to the migrated record. So such migration affects the performance, requiring multiple blocks to read. So this problem may be resolved by adjusting the block present free parameter. However, migration is not a major problem in the data warehouse because of the negligible number of updates. The fourth one is manage block utilization. So performance degenerates when data blocks contain excessive amounts of the free space. Whenever a query calls for a full table scan, performance suffers because of the need to read too many blocks. So manage block underutilization by adjusting the block present free parameter downward and the block present used parameter upward. And the fifth one is resolve dynamic extension. So when the current extent on disk storage for a file is full, the DBMS finds a new extent and allows the insert of a new record. So this task, finding a new extension on the fly, is referred to as dynamic extension. So that is dynamic extension. And however, dynamic extension comes with significant overhead. Reduce dynamic extension by allocation of large initial extents. So the sixth one, which is the last technique, is to employ file striping techniques. So you perform file striping when you split data into multiple physical parts and store these individual parts in separate physical devices. So file striping enables concurrent input or output operations and improves file access performance substantially. So let us now proceed to using RAID technology. So RAID means redundant array inexpensive disk. So this technology has become common to the extent that almost all of today's data warehouses make good use of this technology. So these disks are all found on large servers. So the array enables the server to continue operation even while they are recovering from the failure of any single disk. So the technology can recover data when a disk fails and reconstruct the data. So RAID is very fault tolerant. So here are some basic features of the technology. The first one is disk mirroring. So disk mirroring is the writing of the same data to two disk drives connected to the same controller. So the second one is disk duplexing. So similar to the mirroring, except here each drive has its own distinct controller. And the third one is parity checking. So, and then adding of a parity bit to the data to ensure correct data transmission. So this is adding of a parity bit. Then the fourth one is disk striping. So this data spread across multiple disks by sectors or bytes. So RAID is implementing at 6 different levels. So the RAID 0. RAID 0 is high performance, less expensive, and entire array out even with single disk failure. So RAID 1 is high read performance, and availability, but it is expensive because of data duplication, unlike with RAID 0. So the RAID 2, high performance, corrects 1-bit errors on the fly, detects 2-bit errors, but is costly, of course. The same as RAID 1, it is costly. And then RAID 3, high performance for large blocks of data, on the fly recovery, not guaranteed. Then RAID 4 can handle multiple 1 zeros from sophisticated as used with only 2 drives. And the last level is the RAID 5, which dedicated parity drive unnecessary, works with 2 or more drives, poor write. Here are some indexing techniques. So the first one is the B-tree index. B-tree index technique is superior to other techniques because of its data retrieval speed, ease of maintenance, and simplicity. So most database management systems have the B-tree index technique as the default indexing method. The second one is the bitmapped index, are ideally suitable for low selectivity data. A bitmap is an ordered series of bits, one for each distinct value of the index column. Bitmap indexes support queries using low selectivity columns. So the strength of this technique rests on its effectiveness when using predicates on low selectivity columns in queries. Bitmap indexes take significantly less than the B-tree indexes for low selectivity columns. The next is clustered indexes. Clustered indexes combines the data segment and the index segment. So the two segments are one. Data is the index and index is the data. So cluster tables improve performance because in one read you get the index and the data segments. So queries run faster with cluster tables when you are looking for exact matches or searching for a range of values. The next is indexing fact tables. Indexing fact tables is the primary key of the fact table consists of the primary keys of all the connected dimensions. And the last one is indexing the dimensional tables. So this is the column in the dimensional table are used in the predicates or queries. The next is performance enhancement techniques. So this is the next topic, which is performance enhancement techniques. So let us review some effective performance enhancement techniques. So number one is the data partitioning. So partitioning is a crucial decision and must be planned up front. Partitioning means deliberate splitting of a table and its index data into manageable parts. So the DBMS supports and provides the mechanism for partitioning. So in a data warehouse, horizontal partitioning based on calendar dates works well. So it produces great benefits. Then the next is data clustering. Clustering fosters sequential prefetch of related data. You achieve data clustering by physically placing related tables done to each other in storage. So the next is parallel processing, the last. This technique may be applied to the data loading and data reorganization. But parallel processing techniques work in conjunction with data partitioning schemes. So the parallel architecture of the server hardware also affects the way parallel processing options may be involved. So these are the next topic will be the major data warehouse deployment activities. So the number one is complete user acceptance. So these are the major activities. First is complete user acceptance. So proper acceptance of the system by the users is not just a formality in the deployment phase. It is an absolute necessity. So necessity ang pag-complete of user of acceptance. So it doesn't matter how the user acceptance activity is completed, but do complete it in the manner in which such acceptances are usually done in your environment. And then next is perform initial loads. So in performing initial loads, here are some major steps to complete initial loads. So the major steps are drop the indexes on the data warehouse relational tables. As you know, each dimension table's records is in one-to-many relationship with the corresponding fact table records. Then in some cases, the initial loads may run for a number of days. Load the dimension table first. So Remember how the keys are built for the dimension table records. So recall how the keys for the fact table records are formed from those of the dimension tables. That is why you need to load the dimension table first and then the fact tables. The next is load the fact tables next. So the keys for the fact table records would already have been resolved before creating load images in the staging area. So get user desktops ready. Getting the user machines ready for the data warehouse is a comparatively small part in terms of the overall effort from beginning to end. So although the effort may be much less than 10% of the total activities, what the users see and experience at their desktops is what the set of desktop tools is the data warehouse of the users. So the next is complete initial user training. So the importance of the training and orientation for the users cannot be overemphasized. So the training program must be designed from the user's point of view. So the capabilities of offered in a data warehouse have a much wider potential. The next is institute initial user support. So note that the basic support center. So the user representative in each department is the first point of the contact. The user representative must have trained well enough and is also knowledgeable about the end user tools on the desktops. Also, note the type of support provided by the technical support group. And the next is deploy in stages. So building and developing a data warehouse is a major undertaking for any other organization. This is a project. So deploying in stages is a project that calls for many different types of skills. For the next topic, which is a data warehouse security. So a data warehouse is a veritable gold mine of information. All of the organization's critical information is readily available in the format that is easy to retrieve and use. So in an operational system, security is ensured by authorizations to access the database. So the project team must establish a security policy for the data warehouse. So security protection in a data warehouse through passwords is similar to how it is done in an operational systems. So security tools, these are the tool-based security, being an integral part of the toolset, cannot be suspended. Just to get into the toolset for accessing the data, you need security clearance from the toolset software. So the importance of security is that it secures all of the information of your data warehouse. So next is a backup. A data warehouse is a complex system and it contains a huge volume of data. So therefore, backup is important. So it is important to back up all the data so that it becomes available for recovery in future as per requirement. So the purpose of backup is to create a copy of data that can be recovered in the event of a primary data failure. For the next one, which is the recovery. So it is so important. So recovery from a backup typically involves restoring the data to the original location where it can be used in place of the lost or damaged data. So an efficient and fast recovery of a data warehouse begins with a well-planned backup. So you need to plan a backup so that you can recover all your data, all your information, and all your important information from your data warehouse. So the next is monitoring the data warehouse. So this is the next topic. Monitoring the data warehouse is comparable to what happens in an OLTP system. So except for one big difference. Monitoring an OLTP system dwindles in comparison with the monitoring activity in the data warehouse environment. So monitoring the data warehouse really matters, for it ensures top performance, excellent usability, ensures the business can run efficiently, prevents security issues, and ensures governance and compliance. Moving on to the last topic, which is the managing the data warehouse. So data warehouse management is concerned with two principal functions. The first one is maintenance management. So the data warehouse administrative team must keep all the functions going in the best possible manners. So the second one is change management. So as new versions of the warehouse are deployed, as new releases of the tools become available, as improvements and automation takes place in the ETL functions, the administrative team includes enhancement and revision. So an effective and effective management of the data warehouse makes your business value higher. So that will be all for today's video. Thank you so much for watching, and God bless us all.